The division algorithm is a really handy result that we'll use in a lot of our calculations in this course. It's just a formal statement that says that we can carry out long division and end up with a suitably small remainder. So we know the algorithm for long division. Here on the right we see such a long division taking place. We got 12,345 divided by 13. All the steps are carried out. You get 949 with the remainder of 8. So we could write that as 949 and 8/13, or since we really like to work with integers, in this class we're going to prefer to write that as 12,345 equals 13 times 949 plus 8. And the division algorithm says that we can always do this. I'm sure you've never questioned that since you learned long division way back in 3rd or 4th grade, but now we have an official theorem that says you can do it. And notice the important part here is that the remainder had to be somewhere between 0 and 12 because we were dividing by 13. So the formal statement of the division algorithm, I mean, some textbooks just call it the division theorem because it's the algorithm is not actually part of the statement of the theorem. But we start with two positive integers a and b. Then there will be unique integers q and r, so that a is equal to bq plus r, where that r value is greater than or equal to 0, but less than b. So q is the quotient, r is the remainder term. And our last slide, the b value was the 13, so the remainder had to be somewhere from 0 to 12. So as an example, if a is 362 and b is 7, then we can rewrite 362 as 7 times 51 plus 5. So the quotient in this case is 51 and the remainder is 5. So you absolutely need to memorize the statement of the division algorithm. It will show up in result after result after result this semester.